My name's Brad Beach. I'm an operational excellence manager for Evonik's healthcare business in Lafayette, Indiana, right next to Purdue University, if you're familiar with that. A little about me. One of the reasons I live in Indiana is because my wife's entire extended family lives 5 minutes away from me. And I had previously spent 12 years with Schlumberger, oil field service company, and we didn't have that. So now we have that, and we're really happy. I went to Purdue. I'm a big Purdue guy, let's say. And I will promote something that I think, if you're interested, you should check it out. It's called Strategic Doing. It's a framework for collaboration that's really helped me in my life and in my work. I play guitar in a country band called White River Rambler. Like I said, spent time at Schlumberger, a short time at a startup, and I describe myself as a relentless experimenter and like to leverage the power of networks to get things done. So that's me. And does this control the slides too? Yeah. Perfect. Okay. So, and I've got about, how much time, Janice? 20 minutes?
Take your time.
Okay, no rush. Perfect. So, Evonik's a very large company, specialty chemicals company, with four main business lines. I work in the nutrition and care division for their healthcare business line, and we manufacture medicine at our site in Lafayette. Evonik purchased our site from Eli Lilly in 2010. This is the site. It's a 250 acre footprint, 600 or 700 employees, and really two main production things going on. One is small molecule manufacturing. We make APIs, active pharmaceutical ingredients, like cancer drugs, things like that, in bulk. And then on the right side, we do fermentation. So we make an antibiotic since we've been doing that since 1957, and that also means we have gearboxes from 1957. And I should add that we just announced that we will be building a lipids manufacturing facility starting next year. And I happen to share an office with the project team. So if anybody wants to talk about that, let's talk. So that's the site. This is a bit of the history. Like I said, since 1953, it's been growing and transforming, and today Evonik purchased in 2010 from Eli Lilly, and today we are, we've got 30-some customers and are doing quite well. On the small molecule side, this is, I won't talk about this in too much detail, but this is our manufacturing capability. This does include high potent capability. I think there's some statements I should be making here, like largest high potent. I don't know. I'll be making it up, so I won't say anything. But we have high potent capability, flexible manufacturing. We do everything from small batch validation campaigns to full scale commercial production. And then on the fermented product side, this was how the site started, and yeah. So that's a little bit about our site. So to transition into kind of how we're doing digitalization or becoming, I like to think of this as becoming a digital organization. But digitalization is the word Evonik uses. We start with a metaphor. So credit to a colleague, his name is Arpon Seth. Element knows him well. He's a great chemical engineer and data scientist, but he came up with this and I stole it. So chess used to be a game played between two people, but in 1997, the supercomputer Deep Blue defeated the best human player, Garry Kasparov, in a game to answer the question, who's better, computer or human? And I think today that question's really not relevant. If a human tries to play computer at chess, human loses. But the chess community's been asking a different question. Could a computer kind of assisted, or a human assisted by a computer beat a supercomputer in a game of advanced chess? And the answer is yes, they can. And these cyborg players, in fact, perform better than the most advanced human players and the most advanced computers. And you can see the ELO ratings, which is an advanced analytics sports geek concept I won't explain right now, but it's they're better, is the point. So, but the, let's see, yeah. So but the winning teams, there's a counterintuitive result here where the winning teams do not necessarily feature the best players, the best chess player, and they also don't feature the most powerful computer. These winning teams, they win because the winning team has the best interface between the two. So it's not the best chess player, it's not the best computer, it's the interface between the two. And I really like this metaphor for what we're doing in manufacturing, because we simply, we will win in advanced manufacturing, let's say, with a good interface between the two. And so when we talk about digitalization or AI or machine learning at the production floor, we don't need the best data scientist, we don't need the best computer, we don't need the best algorithm. Maybe they help. But really what we need to do is we need to present this information in a useful way to the operations teams, to the people operating the equipment. The people I say operating equipment, but in fact, we think about predicting maintenance costs, prioritizing inventory release in our internal production systems and monitoring production, things like that. So you need a clear understanding of the questions your teams need to answer every day, and you need a portfolio of tools that will help them answer these questions quickly. And I've been pleased to hear that everybody here is kind of saying the same thing so far. It's really interesting to see. So what I want to talk about is kind of how we're deploying at the factory floor, or a model we're trying to use to deploy at the factory floor. But I'll start with the big picture for Evonik. Starts to look like this. And when I see this slide, I can see, what I like here is I can see the building blocks for a digital organization. I can see the pieces that we need in each of the building blocks. But I get a little bit scared because this is a big, hairy problem to solve. I have no idea how we just kind of go out and do this. And I think when we try to deliver digitalization at a big scale, and we try to go big right away, we tend to fall down. But what I think works is if we try to take and merge, so I'm an operational excellence manager. I'm lucky enough to work with a guy that's done operational excellence everywhere. He has a really refined approach to doing that is experimental, iterative, quick, and is working so far. And we're 6 months into the journey for me. But if we merge operational excellence with, let me skip through all that. No. If we take this is an operational excellence concept called the infinite loop, where what we do is we establish a daily monitoring system, and we try to meet an aspirational target versus our current standard. And then once we know we can hit that, then we change the standard, and that's called the improvement loop. If we merge this infinite loop with agile software development, what happens then? How do we merge, how do we kind of deliver these digital solutions to the teams at the factory floor? And this is how I think we can think about it. So the model that I'm starting to talk about, and this isn't perfect, it needs some work, but this explains how some digital tools have been deployed. And I'm stealing from like the lean startup concept, whatever, but first step is build a minimum viable product to support a minimum viable workflow. In this case, and I'm giving a very generic example, but we have 3 data sources, maybe 1 data table in SAP, 2 data tables in SAP, and 3 data table from the data historian or whatever. Those go into a model where we do some magic. Maybe we do AI, maybe we just do some calculations. From the model, we deliver to a tool. That could be Excel, that could be a Power App, that could be just a printout, I don't know, whatever. But in the end, the team starts using this tool right away. And this workflow is the first step in trying to find a new way to approach a problem. Once we've established and gotten started with this, then the next step is to industrialize the tool, which simply means, automate the tool. So now, frankly, I like to build stuff like this, but the problem I have is I build it and then I have to maintain it. And then I'm stuck maintaining it because I failed to train somebody, and we're working on that. But if we can automate that, then my problem goes away. I don't have to maintain the tool anymore. And we still have the same thing, which is a tool. We still have the same thing, which is a team using this new information presented in a new and better way to deliver, whatever they're doing more efficiently. And then, I won't say we've really done this, but the idea here is then once you've automated that and you've tested it in the factory, you might have another team that wants to use the same thing, and you can scale it very quickly. I won't claim that we've actually done that at a big scale, but it's a work in progress. And what did I have next? Yeah, and so I have a couple examples here of places where we've tested this. So the first one was a maintenance tool. In 2017, in the second half of 2017, we were having a rash of diaphragm pump failures for chemical processing. People, maybe you know what that is. But we're doing production, and the pumps just started leaking all over the place. And it was happening literally every 2 weeks, to the point where in one case we spilled 30 liters of solvent on the floor, which is bad. And then in the second case, we dissolved a piece of a backing diaphragm into the product, which is bad. That means tox studies and all kinds of work to understand what happened. And the problem was actually pretty simple. We were running these pumps to failure, and we didn't know when they failed. So we did a quick assessment and figured out that they actually fail after, on average, 2 days of operating time because of the way our process is set up. It's not great. But if we could calculate the runtime, then and then schedule the maintenance before the failure, then we're good. And that's what we did. And a lot of people would say, well, let's install a counter to count the strokes. And All we did was we pulled in data from the data historian, and we pulled in the maintenance data. We looked up the last work order date, calculated the runtime, scheduled the maintenance, and in this project I call disappearing deviations, which for pharma people is meaningful. But yeah, which is very good. But essentially going from 16 deviations in 1 year down to 4 the next and basically 0 thereafter is also worth $400K in production time. So it was quite a valuable thing. And this again followed the same workflow where quickly develop product. You know, in this case, it's a Power BI model. It started in Excel actually, and then we did a Power BI model, and then it was automated, and then industrialized. If I'm going to keep my lingo rolling. The next one is actually not really well developed, but generates the concept. One of our big challenges today is actually the volume of production that we do is quite high. And raw materials, I don't know if anybody's struggling with those, but they're not arriving as early as we want. And resources are constrained, so people are, really busy trying to just stay organized, like delivering raw materials. And people like our QC department, the lab people over here, he's telling me, he's like, I just need a list of what needs to happen and in the order that we need to do it. Okay, can you just give me that? I said, okay, we can do that. And we did. So we took 3 SAP tables. I'll show 2, but it's 3 SAP tables actually. And SAP's not giving us the answers that we need. So we take 3 SAP tables into a model and we calculate the stock out date. The stock out date we then put into an Excel spreadsheet, and then we put the current inventories, and then we give them a way to select which batches they want to prioritize. And so they get a priority list now, which is exactly what my friend in labs asked for. And then now each of these functions, because there's 4 key functions kind of managing this workflow, now they can see, what do I need to do first? We still have an interface problem, so in fact, I asked them, well, if you don't have some of it, who's looking for that? He's like, not me, I'm not looking for it, but that's a different problem. But this is working. It's a MVP. My friend Arpan, the advanced chess guru, is helping me industrialize the tool now. And we'll see where it goes, but I think it's going to work. And then this, so that's the deployment model. These are 2 examples. In the end, I think we're successful if we can deploy quickly. And this is a simple version of the architecture, but we have our kind of, what's the word? Yeah, data sources. I was going to say old school data systems, but that's probably not the right word. But data sources. We have a manufacturing execution system actually too that's deploying that I would add here. And then we have a ThingWorks environment supported by a contextual data model that we've started to build with help from Element. And then we have our application ecosystem on the top. So the application ecosystem should consist and kind of does consist of these kind of self-developed things. There are standard apps like built centrally in Germany and in the US. Then I think this should be a place where our third-party vendors can plug and play. And if we have a solid middle layer that kind of cleans everything up, then we should be deploying third-party models, applications, whatever, very quickly and very cheaply. We take out the hard part. That's the idea. So, in summary, we'll transform our operations if we build out this ecosystem, really from starting at the production, at the user, and working backwards with an easy way to ask questions intuitive results for the person asking those questions, and an interface that delivers these answers quickly. And to understand which types of applications we just have to continue building a better understanding of this concept in our organization and experimenting at the plant floor. This part's probably the hardest part for me. I don't have the patience, I think, but we need to, learning how to teach. Someone this morning said teaching people, helping them see for themselves what they can do and what's possible here is the secret, and I agree with that completely. And I think it happens through small steps, small experiments. As soon as they can see something working, hopefully the pull comes next. And then to enable these tools at the scale of our plant, we need to continue investing in the development of this middle layer. This middle layer is really important to really make it easy to do this. And yep, I think that's the end. So thank you.